Salam sejahtera and hello to madam. We are from group IMC. Our title is Cafeteria Service Management System. Our group consists of 5 members, which is me, Haris, T. Yongjain, Someshwaran, Tan Lixion, and one Muhammad Zaman. For the introduction, we know a database is widely used in our current tech world. However, back in the day, manual files were used, which resulted in data loss. Database design is a fundamental aspect of building efficient, scalable, and reliable information system. This project creates a cafeteria service management system. A properly designed database is crucial for handling daily operations, including order management, inventory tracking, customer transaction, and reporting. Attention to database structure and relationships is essential to support the cafeteria management system that can handle high transaction volumes and complex interaction between different types of data, such as inventory items, menu options, customer orders, and employee schedules. This database will enhance the performance of the staff and the management to handle the operation efficiently. I will pass to the next person.
Okay. So for my part is the problem statement for this system. For the problem statement, we have 3 problem statements for this system. One is in efficiency, tracking order and delivery process. In traditional food ordering system, tracking the status of order and managing the delivery process can be highly inefficiency. This efficiency often lead to delay, error in order fulfillment and customer dissatisfaction. And the second one is lack of integration with inventory management. There is a disconnected between the ordering platform and the restaurant inventory management. This often lead to customer ordering items that are out of stock and resulting in order cancellation. And the third one is inefficiency ordering process. In the traditional food ordering system, cafeteria always record order manually. For example, the staff will order uh, order with writing in on paper, and this will increase the human error and waste the customer time. And for the objective, we we still have 3, and one is enhance the operational efficiency. This to implement a system that automated the order taking and processing workflow without reducing wait time and error. This will help the staff and with help of tools, this streamline tasks such as scheduling, task management, and reporting. For the same objective is streamline order tracking and delivery. This system will provide real-time order tracking and automate delivery process to reduce delay, minimize the human error, and ensure timely order fulfillment. And the third one is integrate inventory management with ordering. This system will connect the ordering platform directly to inventory management system. This allows customer to view item availability before placing an order. This will minimize the cancellation due to out of stock item and optimize stock management. And now I pass to Mipa.
Good evening. I will be presenting the scope of our project, which is designed to streamline operation and improve efficiency. The project is divided into several keys. The first one is a order management system. This module focuses on order tracking to ensure all orders are mentioned efficiently throughout their life cycle. Additionally, it provides order notification to keep customer and staff updated on the status of order in real time. The second one is inventory management integration. We aim to provide real-time stock update, ensuring the inventory status is always accurate. These include automatic inventory reduction to adjust stock level as orders are fulfilled. The third one is user interface. Intuitive and user-friendly interface will enhance usability, making it easy for staff and customer to interact with the system. The fourth one is supplier management module. This module will help with supplier information management, allowing the system to store and organize supplier details efficiently. It also includes supplier performance tracking to evaluate and manage supplier reliability. Lastly, it links supplier to inventory, enabling supplier inventory tracking for smoother supply chain operation. The fifth one is reporting and analytics. We will include tools for data reporting and analytics to provide valuable insight, identify trend, and support decision making. Lastly is error handling and notification. We will finally we have incorporate robust error handling mechanism to minimize this corruption. Additionally, alert for staff will ensure any issue are communicated promptly, so they will be resolved quickly. That's all from me.
Okay. Good evening, and my name is Lee Yongjian. So I'm explaining about the fact finding techniques that we use in our system, which is Cafeteria Service Management System. Okay, so first, to gather the necessary information for our system to design, we employ two primary fact finding techniques, which are interviews and observation. First, talking about interviews, we conducted the interviews at the UTM Cafeteria 1 with one of the staff members. As you can see in our slide, there's a picture during our interviewing session. And during the interview, we try to aim to understand the daily operation, changes, phases, and the specific needs of the cafeteria staff. This direct interact provided us with valuable insight into the workflow, menu, menu management, and customer service progresses. And second, about the observation, in addition to our interviews, we observe the cafeteria operation during the peak hours. This allows us to see the first-hand how staff interact with the customers, manage orders, and handle inventories. Observation help us identify the areas for improvements and understand the real-time challenges faced by the staff. So proceed to next. What is the type of database management system we use? In our system, we choose to use the relational database management system, which is RDBMS. This choice is based on several factors. First is the structural data. This relational model allows us to organize the data into structural table, making it easy to manage and retrieve information. And then second is ACID compliance, because relational database management system ensures data integrity and consistency through ACID properties, which is crucial for managing transactions in a cafeteria setting. And then last is SQL support. By using the SQL for querying and managing the database, provides the flexibility and efficiency in handling the various operations, such as ordering, processing, and inventory management. So that's all for the type of data management system we use. Next, I will pass to my member to explaining about the ERD.
I will explain the relationships in the ERD for our cafe management system. Before we dive into the relationships, it's important to note that each table in this diagram has a unique identifier, which whether it is or the ID, item ID, or inventory ID. These unique IDs form the basis of the relationships within the system. So let's start. The first is item inventory relationship. The item inventory relationship connects the inventory and item tables. It uses the attributes inventory ID and item ID to track which items are stored in which inventory. Additionally, it includes the last updated attribute to record the most recent changes. Okay, next, let's take a look at the item order relationship. The item order relationship links the order and item tables. It connects order ID and item ID to detail the specific items in an order, along with the quantity and the subtotal of each item. Next, the stock relationship ties the inventory and employee tables. It uses inventory ID and employee ID to track which employee is responsible for restocking a particular inventory. It also includes restock quantity and restock data to record the amount and date of restocking. Next, let's go to the order and payment relationship. The payment entity is linked to the order table through the order ID. This connection ensures that every payment is associated with a specific order. Payments are also linked to employees using employee ID, which tracks which employee managed the transaction. So let's go to the order cancellation relationship. The order cancellation table is related to the order table via order ID. This relationship allows the system to record cancelled orders along with attributes like a cancellation ID and a cancellation reason. Yeah. Next, let's go to the order table, which has its own specialization. The order table includes a specialization for dine-in and takeaway orders. For dine-in orders, there's a relationship with the table entity using table ID, which identifies the table assigned to the order. For takeaway, we have the completion time attribute to record when the order is ready. Next, let's go to the employee and table management. The employee table is connected to the table via employee ID, indicating which employee manages a specific table in the cafe. So let's go to the customer feedback relationship. The feedback table is linked to the customer table through the customer ID. This relationship allows the system to associate customer feedback and ratings with specific customers. Then let's talk about refund and payment relationship. The refund table is linked to the payment table using payment ID. This relationship ensures that every refund is tied to a specific payment with additional details like refund reason and refund date. I think that's all for me. I'll pass to my friend for the next part.
Thank you. Next part is transaction pathway. As you can see in the ARD, we can see some red arrows which indicates the transaction pathway between the tables. For example, we can look at the customer and the order table. when customer places an order, the customer ID will be included in the order table. So let's say if the user want to identify the customer's name and IC number through the order table, we can join the customer table and order table using the customer ID. Or we can also search the order details using the customer table by searching the customer IC number. Next example is for order and order cancellation table, the relationship between that. Cancel orders are tracked separately, which indicates a table with just cancellation ID and order ID as the FK and the cancel reason. For example, if you want to find out the order details of the cancelled order, we can just join the order cancellation table and order table using the order ID. That's all from our group. Thank you.